Coming to the next question, this in fact is a wonderful question. Who would have expected this type of question in mains? This is something that should appear in advance. Organic compound X having same atomic ratio of carbon, hydrogen and oxygen. So, it should have all three same. Is treated with KOH followed by H plus. Okay. So, alkaline medium is then followed by acidic condition to form the product P, and we have to identify the structure of that product P from the following. As all these options appear, I have two choices. Either my original compound should have been of 2 carbon or it should have been of 3 carbon, right? Why did I say so? See, option number 1 and 2, you see there are 2 carbons. Option number 3 and 4 are of 3 carbons each. And it says organic compound was only one, X. Correct? So, if it was only organic compound X, assuming it was aldol, then the product should have even number of carbon atoms. So, third and fourth could not be in my choice as it has odd number of carbon atoms. Assuming it to be aldol, because KOH is there, that is the first thought that will come into our mind. Second thing is aldol is not possible. If I go to first and second, then it is having 2 carbon. If it was aldol, 1 carbon compound do not give any aldol. So, let's eliminate aldol from the option. Second could be Canizaro. Now, Canizaro is alcohol and acid salt. Okay, followed by H plus, so I can say acid. Still the problem remains. Then the two products will be formed. Oh, but there is something which is quite similar to intramolecular aldol called, sometimes it is called benzyl benzoic acid rearrangement type thing is there. Even if you don't know the name, doesn't matter at all. Let me tell you what I am suggesting solution here. So, see, this type of compound glyoxal, okay, this satisfies that condition of count of carbon atom, hydrogen atom and oxygen atom are equal. That part is satisfied. Now, it is treated with KOH. As I said, reaction is quite similar to Canizaro but is not Canizaro. Okay. So, nucleophilic attack, pi opens. What did I find? C, H, OH and O minus. Right. Next step is O minus gone. Intramolecular hydride shift. In Canizaro, it is intermolecular. Here it is intramolecular. CH2 O minus COOH. Of course, conditions are basic. This will have intramolecular proton exchange. Till here, it was in presence of KOH. Now it says add H plus. So, CH2 OH COOH will be the structure of the product P. Absolutely fine. You have got the reaction that is there. Somewhat you can say is Canizaro type reaction, but this is not the reaction you will easily get from NCERT. Little leveled up reaction, I will say. Answer by this logic is option number 1, CH2OH COOH. Alpha hydroxy acetic acid, alpha hydroxy ethanoic acid.